hello. So please come in. If you are just coming in, please come in. You haven't missed anything yet. So EuroPython is in Prague this year. So it's very good because you just take a train. You don't need to get your passport or whatever. Because last year was in Dublin and people complain about, oh, I have to fly and bring my passport and stuff. You don't have to. So it's like 17th to 23rd of July. So it's going to be nice weather, very beautiful city, lots of cheap beer, wine, drinking will be fun. So EuroPython, we have actually now finalizing the schedule. There will be a lot of amazing talks, and we would also have a lot of different activities. So there's like 2 days of workshops, tutorials, 3 days of conference, 2 days of sprints. You can spend your whole week there. Bring your family. There will be childcare. There will also be other things like CPython core developer panel. There will also be like maintainers panel. There will be lots of events like mentor sprint. There will be a humble data workshop, which you have heard about it the first day. So lots of things to do, lots of fun. So please come to Prague, and we can have ice cream together. Yay! Okay, that's it.
All right, thank you. Up next, do we have Rick Wagner in the crowd?
Yes, Rick, you're giving a lightning talk. I have your slides. So let's play a game in the room. Who knows Never I Have Ever? Never I Have Ever submitting a lightning talk for someone else and they haven't seen the slides.
All right, so I'm going to ad-lib. It's great to see everyone. Actually, you know what? I've got something. This is going to be corny as heck. So my wife has been working as a prompt engineer, learning how to get ChatGPT to say the things that she wants. And she tries to reach out to me, I'm the more nerdy, techie one in the relationship. And she first started writing pickup lines using Kubernetes as the prompt. But last night, she tried to make one using Jupyter, and it ended up being far more endearing than I thought. So it's like, hey, are you a Jupyter notebook? Because just like how Jupyter notebooks make data science more interactive and fun, you make my life more exciting and enjoyable. I can't wait to explore all the possibilities with you by my side. There we go.
Yeah, there is 11 slides.
Thank you, Rick.
Okay. Identity management and impersonation in the JupyterCon Lightning Talk submission system by Rick Wagner. Yeah, I submitted this clearly. Outline of the talk. So who am I? What is the Jupyter Security Project Subcouncil? And what is the vulnerability that we demonstrated to give this lightning talk? So I'm Rick Wagner. You can tell by the beard. And I think the same, maybe the same jacket. So what am I doing here? I'm reading from slides that were just given to me right now. And let's talk security from the perspective of my slides. So there is the Security Subproject Council. Matthias, the colleague that obviously did not submit these slides and impersonate me, has helped to initiate this activity. And we also have help with Jason Grout, Roland Thomas, myself, Jason Wow from AWS, and Joe Lucas, who gave a talk today on vulnerability detection. And so I am the current sub-project representative to the Security Council. So please, if you want to talk about security in the context of Jupyter, you can join our weekly meetings or reach out to any of us directly. So if you go to jupyter.org/security, there is some how to submit vulnerabilities, how to find us, et cetera, and a mission statement. And I drafted this mission statement to give us some focus, and since nobody objected, it's now the mission statement for security in Jupyter. So Project Jupyter is committed to reducing risk in using, deploying, operating, or developing Jupyter software. And I drafted this one sentence based on the way Jupyter's mission in itself in having a broad community. And the community is not just the users, it's not just the developers, it's everyone who benefits from Jupyter, and this role of security in Project Jupyter should be the same, to drive the mission of the project as a whole. By the way, it says jupyter.com. Do we have that domain name? So
Good
there
question.
you go. All right, so don't follow that link. We have the security repository repo, the security repo. This is where we keep our meeting minutes and things like that. You can see our activities, find our meetings, and stuff like that. And so this is for public conversations. We try to do as much openly. And when we do stuff in private, we try to be open about how we do it, even if we can't get into the details, say, of a particular vulnerability. We want the process to be documented and to be clear about who is engaging in what private conversations and why we would not have everything be fully open. So bi-weekly, Tuesdays, 8 a.m. I think we do the first Tuesday and third Tuesday. Okay, anyways, it's on there. You can look it up. 8 a.m. Pacific Daylight and Savings Time, which is why I'm here to disclose responsibly. Yeah, okay. This meet? Oh, yeah. Oh, yes. We don't talk about specific vulnerabilities in that meeting because it is public. You should submit those following the security@ipython.org email. And I think
Next.
payload.
Should be a video.
Okay, so this is how I ended up giving this talk, is somebody wrote my name down and put it on the deck, and suddenly I am here to give a presentation. So that's all it takes. And then, is that me in the background? You were holding your phone while you talked to me. Yes, he was. Okay, so, oh. And to think, I walked in this afternoon, and I looked at Paul, and I'm like, oh, you look kind of good today, you know? Like, and he's like, yeah, it's almost like you couldn't tell us apart. Yeah. Uh-huh. So, the next time you want to give a talk, or someone who looks vaguely, almost totally not unlike you in the same way like the cup of tea is not totally unlike a cup of tea in the Hitchhiker's Guide to the Galaxy, you too could submit something. Thank you. Thank you for
Thank you, Rick.
Excellent.
Don't worry, your social was not in a light font somewhere. Okay, next.
Okay, next up is CoCalc, Collaborative Calculation and Data Science.
And you can.
Hey, how's it going, guys? My name is Blake Bejarano. I'm the Chief of Sales for CoCalc, Collaborative Calculation and Data Science, created by Sage Math Incorporated. And I'm here just to let you know a little bit about our platform. So CoCalc provides access to open source tools for science, engineering, and mathematics with an emphasis on continued access and real-time collaboration. That way you can collaborate in real time via your web browser while using popular applications like Jupyter Notebooks, Linux Terminal, LaTeX or Markdown documents, VS Code, X11 graphical desktop. We have an integrated course management system for those in the education space who would like to automatically grade Jupyter Notebooks. And we're the first company to come out with a computational whiteboard environment, fully featured whiteboard where you can write using a pen and a tablet, make sticky notes using LaTeX or Markdown or rich text for mathematical notation, and run Jupyter cells in any of your favorite open source programming languages. You can use Python, R, Julia, Octave, C++, JavaScript, Fortran, Root, Sage Math, of course, and even custom kernel environments. CoCalc is available to use absolutely 100% free online when you use shared resources via our Google Cloud Cluster. And if you purchase a license, you have fully configurable dedicated resources, RAM, CPU disk space, and idle timeout. We offer dedicated disks and virtual machines. But what's really unique about our company is that we're project-oriented, not user-oriented. That means that you can apply a license to as many projects as you'd like, as long as the maximum number of concurrently running projects is not reached, and you set that via run limit. And the other thing is you can add as many collaborators to use your project's resources at no additional cost. Here's my little bit of information for you guys. For $4 a month, you have 2 gigs RAM, 1 CPU, 3 gigs disk, 30-minute idle timeout with network access and member hosting. And you can add whoever you'd like to use these resources, and it's fully scalable. We can serve you any kind of resources that our Google Cloud can. We also have a Docker image that's available for free for academic and hobbyist purposes. And we also serve Helm charts for your own Kubernetes instance if you'd like to self-host on Azure, AWS, Google Cloud, or on your own infrastructure at your institution. Thank you very much for your time.
All right, thank you.
Next speaker.
Yeah, do we have building apps the laziest way?
Yeah, so it's just a very short talk. I work in a small startup that's called Prefix. And I am the original author behind Mamba, and I was super happy to see so many people that like Mamba, and we have something up our sleeves. So the first thing that I wanted to briefly pitch is that we have done it again, and now we've worked on a library that's called Rattler, and it's really just the foundational pieces to deal with Conda packages, and it's written in Rust. And it's basically for our company the fundamental library, and we use it in the backend. We use it in our new build tool that's called Rattler Build, and we use it in the new package manager that I'm gonna show in a second. And Rattler Build is I don't know who is familiar with Conda Build, but Rattler Build is basically the equivalent. It builds Conda packages, but it's a Rust-based tool, and in my opinion, it has a better recipe format. It definitely has a faster execution and very helpful output. And then I wanted to tease the new tool that's going to be called PX. And it has a slightly different workflow than Mamba or Conda. And it combines into the same tool Conda log, Conda devenv, and Conda x. And later, also Conda build. And we will see what we do with pip support. And maybe I can find our new teaser page where we have our cute mascot. And an as-cinema of this new tool. So basically what you do is you can init a project, and then it generates automatically a TOML file, kind of known to the Python people, similar to a PyProject TOML. You can have custom commands in that TOML file. You can add dependencies to your project. You can run that custom command, and then you can sync your environment with what you have defined in your TOML file. That will just go to CondaForge, download the packages, and link them. And it will create automatically a log file. I don't know who here is familiar with Cargo, but we definitely stole a lot of ideas from the Cargo package management system, or Yarn, that do this since a long time. And yeah, that was all.
Thank you.
It's going to come out in maybe 2 weeks from now.
Tomorrow on sprints, during the sprints.
All right, what is CRA is next?
Is it you?
Is that
yeah,
you?
It's our guinea pig.
So I have submitted the talk twice, actually. So that was yesterday, and then today I just feel fancy speaking a little bit of French. So, but I am not very good at French, so I may butcher it. So, qu'est-ce que c'est CRA? Je ne sais pas comment l'expliquer en français. Je passais donc à l'anglais. So, okay, the fun is ended. So now we're talking about something more serious. So what is CRA and why we should care about it, and how it can affect open source and probably you as well. So I don't know why it's like that, but I think it's switched to the right. But remember the GDPR that we have now? Everybody have these cookie thing that pops up when you go to a website. It's like, agree? Do you want to eat the cookie? Yes, no. So yeah, it's you can see the similar thing. Is sometimes lawmaking can actually affect all the technology that we are using. So now we have this CRA coming. So what is CRA stand for? So CRA. I forgot to put the full name here. It's the Cyber Resilience Act. So it's a new kind of act that's proposed in the European Parliament. And basically, the idea was, the intention was good. It's actually putting this symbol we are very familiar with on your software. So all these, for example, the kettle that you use, all this to make it safe, that it doesn't go into explosion. We trust this symbol, right? So it's passed the test, and everything is fine, and you can use it without, explosion. So you just boil the water safely. But we want to have it in all our software as well. So you think, oh, maybe, yeah, it's a good thing, right? So we are more safe, we won't be hacked so easily, and the code will be safer and stuff. But we're talking about open source here. So a lot of open source projects, it's like this, right? Someone was building a small things, and then they don't have much resources. They're just maintaining it themselves for decades. And everything is building on top of it. Yeah, so it's kind of, if you think about that, how can we get this like symbol to make it compliance, right? How to check every code, everything is good and stuff, but it needs resources, and a lot of open source projects, they may not have the resources, and also they don't, they can't be, kind of promise that they would pass this, and all these other commercial product building on top will be fine as well. So, but people are now like reading all this act and stuff and looking at this fine print. So there's actually, so to be fair, they have a non-commercial extension within the act itself, but then the problem is that what is a commercial activity? There's a lot of gray area. What about some project that accept donations? Does it consider, and like, what about, there's a company that they have an open source product, but they also have the cloud product that is paid, like, does it work? So how about, some company, they let their employee to contribute to open source in the office hour? Is it going to work after this, and yeah, so all this stuff is going to, like, we don't know how it would affect us. So what should I do? We are now, like, hurting about this, like, like hearing it is like, oh, what should I do? Get more information out and voice out the concerns. So this is the most important slides of this deck, because these all these like blog posts I've seen, like for example, the PSF is saying something, Internet Society is saying something. There's also like blog posts that people are discussing about it. So read more about it, read the CRA itself, and then if you have any concern, especially if you are like, you're using that for work, like open source project for work, then definitely have a look. And if you have any concern, now is the time. It's still kind of early stage. It hasn't passed the law yet, so we should all concern about it. So thank you. Oh, is that how you're kind of counting down and like creeping on me and stuff? Okay, thank you.
All right. Next up, the virtual research environment. And then after that, we have app mode and app store, not just for computational material science. Are you here?
So I'm Dominic. I am with CERN, and my team is part of the European Open Science Cloud project, and we built something called the Virtual Research Environment, an analysis platform. The thing is that data volumes are growing not only at the LHC at CERN, but and technologies of CERN have been to manage and process data have been adopted at other collaborations. And are facing similar issues, like we've heard at the conference many times before, reproducibility and data preservance. So the challenge is to have a common research infrastructure that would foster an economy of scale, collaboration across domains, scientific reuse, and sustainability. And on the pictures, you can see some of the experiments and collaborations we're involved with. And these EU projects like EOSC Future that I'm part of promote these efforts to have a federated data management and transfer service, distributed data processing, software sustainability, and the analysis, preservation, and reusability. So this results in our virtual research environment, which is an open source analysis platform, where researchers have access to all the digital content needed to develop, share, reproduce end-to-end scientific results in compliance with FAIR principles. One use case where this is being used already is the search for dark matter limits, which both high energy physics and astrophysics are involved in. And there's different ways of doing this: direct detection, the colliders, indirect detection. And having these complex workflows in one platform helps the researchers to collaborate and do their work. So the building blocks of the virtual research environment are the data management, of course, the experiment data, then analysis frameworks, authentication, and of course a front end, which is a notebook, Jupyter Notebook. Yeah. So the core, the heart of the service is a data lake managed by Rusio. It was originally developed by the Atlas experiment to manage their data needs from the LHC experiment, and now serves in our data lake for the distributed data infrastructure, with many instances across Europe, which you can see on the map here. And yeah, and as a front end, of course, we have a Jupyter Hub service, with many customizations and profiles specific to our needs, to the community needs. And some extensions like this Rusio extensions where you can, scientists can easily browse data from the data lake and do some preliminary analysis and prototype some code on the platform. And then to scale out, we have work schedulers like Dask, but also connections to high throughput and high performance computing, which is done with another tool developed at CERN, which is called Rihanna. It's a reproducible analysis platform focusing exactly on reproducibility and preservation of these science workflows. We have extensive monitoring and testing across our infrastructure, which we do with Grafana. And everything's open source on GitHub, so you can find us under a virtual research environment. We're currently transitioning a lot of stuff from previous project, previous organization. So beware that there's still a lot going on. And yeah, everything runs on Kubernetes. We use a lot of these common tools there. And yeah, that's, oh. Really didn't see that coming. Thank you.
Thank you. All right, up next we have the Binder Lite demo. And after that we have NB reproduce, some more things to embed. Are you here?
So we've heard a lot of Jupyter. I'm UV. I work on various Jupyter things. We've heard a lot about Jupyter Lite, and people love using Binder. But Binder, run by volunteers, has some amount of sustainability situation. It also sometimes is slow because Docker can be slow, building complex things can be slow, and it is somewhat expensive to run. So I've been working on Jupyter Lite, which reuses a lot of the code from Binder, but basically just builds Jupyter Lite repos. So this is just a demo. So I have it, I'm giving it my GitHub repo ref, and then I hit launch, and it's just, it just built once, and then I have a working notebook with, if I look at the environment.yaml file that was used for this, this is just a regular one. There's NumPy, matplotlib, and whatnot. So if I do import NumPy, it does actually work. So these are pre-built through that. It also solves one of the other annoying problems with my Binder, which is you cannot just copy the URL of wherever you are and give it to someone. But because Jupyter Lite is all static files, say I've just switched to a different browser and copy-pasted the exact same URL, and then it just works, right? So this makes sharing things so much easier and less confusing, and people don't have to hear the word Kubernetes. And because I am reusing large parts of the Binder Hub code, it means I can also do things like build a Zenodo DOI into a Jupyter Lite thing as well. So this, I just copied the same files from the GitHub repo into this, but this means, again, all of the same stuff works here. This is a fairly new project. I've not put a lot of time into it, but hopefully this can be eventually stood up as an alternative to the regular mybinder.org service. There's still a lot of limitations running in the browser, but I do think for a lot of use cases, this would work well. And it is easier than setting up your own Jupyter Lite, continuous integration deployment system for hosting your own stuff. So if you're interested in working on this or using this, please do reach out to me. Thank you.
Thank you, UV. So next on deck?
Yep, next is NB reproduce, and then we have Zeus Octave. Are you here? Okay.
Yes.
All right. Hello, everyone. My name is Mridul Seth. Like 2 days back at Lightning Talks, I showed something called Jupy Embed. For the people who are not there, it basically lets you embed your data inside the metadata of the Jupyter Notebook. It's not a good idea. Don't do that. But on that note, I like embedding things. It's a JSON file. What can I do? I have to do something, right? So So the other thing that I kind of worked on, I think this is a better idea than what I did with Jupyter Embed, is NB reproduce. So what it does is that you can, so let's say you have a notebook and you want to reproduce this notebook. Yes, you can open Jupyter Lab, you can open Jupyter Notebook, you can run the cells, you can use NB convert to run it with the CLI option, but you still need to worry about the environment. So what this thing does here, it downloads the Docker container, it runs the notebook inside the Docker container, it mounts the file, and it writes the file that is executed inside the Docker container in that environment to your current system, and you have something called now hello world reproduce. So in theory, it should be the same as, like assuming you have the Docker image is the perfect environment for that, it should just work. So, and I'm doing this on a remote machine, so I can't just open up the file. So I'll use something called nbterm. And like this was the actual code, you run it. I can't show the matplotlib with nbterm right now, but so that's the basic idea. And like where the thing actually, so this is the raw JSON of the notebook, if you look right here. And they have, the notebook would have something called Docker image. And this, again, latest, don't do that. You should not, like the tag should never be latest. But it just adds a Docker image inside your notebook. And I don't know if this is a good idea, but like, I feel like a lot of people would want similar things, where like, you can reproduce. You just have this one notebook that you double click on that or something like that, and it just runs in the environment you want it to run in. So if other people are working on this, or like you have ideas, I'm here today. I'm here for the sprints. Maybe we can come up with a saner solution. But until then, this is what I do. So thanks all.
Thank you. Up next, we have Zeus Octave. And then
on deck?
On deck is CodePad, I believe.
Phoenix?
OK.
OK, no worries. And as you may know, someone stole the Lightning Talk box, probably because it was beautiful art made by me and Sylvain. So we don't have any more Lightning Talks on deck after. So if yours is lost or you have one that you just imagine in the last few minutes, feel free to come down and we can do one or two. If you see a Lightning Talk box somewhere on sale, just let us know, we can call the police.
Hello, I'm Antoine. I want to present you Zeus Octave. This is a Zeus-based kernel for the Octave programming language, which recently joined the Jupyter Zeus organization. So for those of you that don't know, Zeus is a C++ implementation of the kernel protocol. So basically, IPy kernel written in C++. And because Octave is also written in C++, it means we can create a kernel natively without depending on Python or IPy kernel, which means that we can create a kernel that is lightweight and also directly access the internal representation of the interpreter to have rich output, parsing of the data structure of Octave, and so on. So I'd like to present the creator, Giulio, of Zeus Octave, who started the project as a side project for his course in Octave, who is not here today at the conference. So what do we have? We have a beautiful documentation that I'm going to illustrate. And so if I have my Jupyter Lab, for instance, I'm going to restart for you all here. So it's snappy. We have the graphical toolkit, image display for the Octave plots. We have also a Plotly extension that is built into it. So now if you have the sombrero here of Octave, you can turn it, zoom it in and out. So here for a more advanced example, this is all available on the Zeus Octave repository. We have rich representation for matrices as both HTML table, as you're used with in Python, Panda, and NumPy, but also as LaTeX representation. You can get your favorite one-based indexing programming language in the notebook. We have rich structure representation. We can have the different Octave package and represent, I don't know, symbolic equation as LaTeX math. Support for input, output, standard input. Oh. Is working properly. We have the help that is given as expected. What else do we have? Yeah, image representation. No, this one doesn't want to. Well, still does work. But yeah, so that's it. You can give it a shot. And so it being all native, we can hope on building a Jupyter Lite version of it, which will be easy to deploy for the classroom, for instance. We also working on, mostly Julio is working on using the XWidget library to provide Octave widget binding, which would be pretty new, as far as I'm concerned, to have this in a notebook with Octave. And also working on cell magic. Thank you.
So you were first, I think, no? So why did you call it Xus Octave and not Xus, 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 Xus?
I guarantee I'll be really quick.
Editing until the last minute.
Oh, hold on. I should use unified.
Yes, type your passwords in clear and your SSN.
Huh? Say it again. Oh. All right. Thank you all for staying with me until the last moment. You probably recognize me from the CodePod talk, but here I'm talking about another project I'm doing. I call it Phoenix, and I call it the laziest way to build AI or data apps in Python. So how lazy can you be? You probably heard many apps frameworks talking about building apps in Python, but we are the laziest way because all you need is to have the Python function that you have to write anyway, and boom, you get a web app. What we did was we rely on the type hint in your function signature, and based on the typing hint, we find the right widget for you. So for example, here is a string type variable. We just give you a text box. Here's a string as a return, so we just print a string. And to show you more complicated cases, for example, if you have a Boolean variable, then you have a switch. If you have a range object, then you have a slider bar, or if it's a literal type, you have this redo button to select it. Let me show you the code to prove you that I really did it. All right, yeah, so here's my code. It's just that simple. So I have a function called hello. I have x as a string, time as a range, is repeated as a Boolean variable. But hold on, I think I need to show you one more thing, which is I call it con.py. Yeah, so this is actually my full signature. Sorry about the typing because I was just finished it. So you have three variables, x, times, is repeat, and a. So they are all of different types, and then we got different widgets for you. So that's what I call it, the laziest way to build web apps. And we support lots of advanced features. For example, we allow you to do layout control very easily. You just do you can read the document how to do it, but for example, here's another demo we made. So suppose you're sending a package to a friend, you can use our app to easily build a shipping label generator in Phoenix. Just write a function with all these, each of the blocks is a variable, and then boom, you call a web API. For example, here I call it easy post. Then you got this, oops, hold on. Then you got this shipping label, and I call the easy post API. They will return me a URL. I just need to say, hey, this URL is an image. Then our web app will render it as a picture. You probably noticed another picture of mine. Another demo picture. For example, this one is a cat, right? So we call ChatGPT's we call OpenAI's Dolly API and returns a picture. yeah, so this is our project. And feel free to give it a try. And if you like it, give us a star on GitHub. Remember, lazy is the way to build web apps. Thank you.
Thank you.
Thank you.
So last one, I think, or do we have someone else on deck? One more after, and then we'll go to the closing remarks. We really need to use your app to print the JupyterCon badge next year. I think it would be much easier than what we had to do this time.
Something happening. Oh, I need to change the parameters.
So who is coming tomorrow? Yes.
Okay, so what I want to show you, oh, maybe put that in big also, is just a widget that we have, and it's called IPyAladdin. You can install it with pip install and all those kind of stuff. But if this lightning talk had a title, it would be Jupyter and Jupyter, and that would make no sense, but they have two ways of writing them. And so the thing that IPyAladdin does is just allowing you to see any public data that is made by a space agency. The surface may be either for the planets or the sky. And what I do here is just I opened the example directory here on our repo and show you what we have. So I will restart the kernel so that we see that I'm not doing funny things to you. I have a single cell. I'm importing the widget. I give my favorite spot in the universe, and I just put a few of things, and I ask it to show me. So that's one place in the center of the galaxy. I can interact with that. I can do whatever I want with it. I can also put it full screen in my notebook, because that's more of a wow effect. But I can interact with that with Python and the other cells. I can also start that in another notebook with the same kernel and interact. And I also wanted to bring you, I don't know, maybe on Jupyter, because it's where we are. And I told you, so let's go there. And give it a bit of time to find the data, because my Wi-Fi is a bit slow. Oh, this is the demo that doesn't work. Let me try to find what's happening. I go in small. Do I have an issue? I don't know. Let me restart that. I guess the server for Jupyter is out. Let's try to go on I/O, observed by Cassini. See what's happening. Nope. I'm totally out of internet. Can't change my position on the sky, but please go and have a try. It's really easy to install, and it's your data.
I think with the last one.
That's the last one.
Yeah, but I was
Oh, one more. So let's do quick, and after we can do the wrap up. Sylvain, is that okay? Where is Sylvain? We can do one more after this one? Yes. Chief says yes. So what's your favorite part of JupyterCon? Dessert? Friends. Friends. Better than friends? The lightning talks. So no one likes us? Oh, ah, thank you. And my favorite part is Jason.
Okay, I just saw somebody using NBTerm just before, so I thought I would talk about the next version, which is called JPterm. So NBTerm allows to run a notebook in the terminal. JPterm can do the same and more. So, for example, I can launch a terminal. What can I do? I can open a text document. There's not much in it by project. A PNG, woo. Markdown file. Why not? There's a table of content here. Ooh. There's some inline code in it. OK, looks good. What else can I do? Widgets. Not this one. A notebook. It has IPy widgets. Well, not really IPy widgets. We call it YPy widgets. They are collaborative. That's a switch, the simplest widget we can think of. Yeah, it works. That's it. It's very much in development. It can also work with a server, even collaboratively with the Jupyter Lab. So you can change some text in Jupyter Lab and have it reflected in Jupyter and the other way around. Thanks.
Thank you.
Thank you. Was one last, Sylvain? Can we? Yes? Go away. You know, I realized that if you take each of the characters of the terminal and make it square and really small, you could have like better definition for your PNGs. We could call them, like, you know, instead of character, pixels. No. Okay, and big applause for our last speaker of the day before our closing remarks. Keep the best for last.
Which display?
It's fine. It's shown above, so you just works.
Great, thanks. I just want to show something that if you didn't see Franklin's talk earlier, you might not be aware of. So there is a JupyterLab extension called JupyterLab Mist. And what that does is that adds in a new default Markdown parser using the Mist.js library. And what that does is you still get all your normal Markdown, but it adds in a bunch of directives based on Mist that allows you to do extra things inside your notebooks. The aim is to get you to the point where you could write a whole scientific paper in a notebook with support for referencing, cross-referencing, and all cool things like that. So I just want to go and show you a few things. The first thing is, if you put a YAML cell at the start head of your notebook, it will render you out a nice title block, full with all sorts of things like ORCID ID, journal-style headings, license codes, etc., with the links to your licenses. It also has things like the Mist admonitions and interactive bits in your Markdown cells. You can also reference your figures and then see your figures at other places of the notebook via pop-ups. That's the same for your equations and things like that. Your equations get figure numbers, and they also come in pop-ups. So you could have a long notebook, and you can see things in different parts in context, which is what Mist is great at. And now you can do that all now in JupyterLab. You also have tabs and widgets, etc. The other thing that comes in is also inline evaluation. So now you have inline code evaluation in the code cells, in the Markdown cells, which means you can interspace numbers and variable values, etc., beside your results. They can also be, hopefully this works, IPy widgets. This is a Markdown cell where you're controlling where to position the widgets around in your text. You can have inline images in there, and you can even have these funky little sparklines that are matplotlib generated, but you're able to also go in and plant those directly in your Markdown. And that's JupyterLab Mist. Try it out. And I have to run the notebooks. Let me see if I run the notebook. And that comes back. Yay, OK. And so go and try it out, install it, and have fun. Thank you.
Thank you. So now Sylvain. Big applause for Sylvain, who organized the whole conference by himself.